Today in the workshop, we'll be looking at the NVIDIA Jetson Nano, a development platform for artificial intelligence. After examining the Nano platform, we'll install Ubuntu Linux 18.04 and the NVIDIA Jetson SDK. It's an intelligent episode today, so welcome to the workshop. Hello and welcome to the workshop. Today we're going to be looking at an artificial intelligence experimenters platform. Now this is the device over here. This is the NVIDIA Jetson Nano, and it's part of the NVIDIA Jetson series of artificial intelligence development boards. Now you may not be familiar with the other Jetson series boards, and that's not too surprising. They're rather expensive. They range from about $300 to about $1,100. But this one changes everything. This is a $99 board that brings all the power of AI down to a level where experimenters like us and students can afford it. Now, there is a lot that you can do with this board. This board is based on the same technology as the other Jetsons, and it can use a lot of the same software, specifically the software included in the Jetpack utilities provided by NVIDIA. Now, what we're going to do today is we're going to take a look at this board. We're going to basically install an operating system on it, get familiar with its features, and then we're going to be using it in other experimenter projects. Now, as you can see, this board looks a lot like a single board computer, but as you're about to discover, it's a lot more than a single board computer, and as you'll also notice, I seem to have two of them. The reason for that is I'm going to be incorporating this onto my DB1 robot as well. But before we can do anything with the NVIDIA Jetson, we need to know a little bit about it. So let's go and take a look at the Jetson right now and see exactly what this platform is. The NVIDIA Jetson Nano Developer Kit was announced in late 2018 and was released in the first quarter of 2019. The kit retails for $99 and is available from NVIDIA as well as a number of distributors including Pimoroni, Amazon, and SparkFun. The kit consists of a Jetson Nano module and a carrier board. It uses a microSD card with the NVIDIA Jetpack SDK software. The NVIDIA Jetson Nano is part of NVIDIA's Jetson family of AI development boards. Now here are some of the Jetson development platforms. There is the Nano, of course, which we're looking at today. It has a power of 0.5 teraflops, consumes 5 to 10 watts, and is priced at $99. Next up is the TX2. It has a power of 1.3 teraflops, consumes 7 to 15 watts, and is priced from $299 to $749 US. And then there is the Jetson AGX Xavier. It has a massive power of 10 teraflops, consumes 10 to 30 watts, and is priced at $1,099. The Jetson Nano is capable of running multiple neural networks in parallel. It's useful for image classification and segmentation. It can also be used for object detection and can be used for speech processing. The Nano is based upon the Nano module, which is available separately. The module uses a 260-pin SODIMM connector. The production versions of the Nano module use NVRAM instead of a microSD card. The specs of the Nano are impressive. It's a quad-core ARM A57 1.43 GHz CPU. It has a 128-core NVIDIA Maxwell GPU. There are 4 GB of high-speed memory. It has a 40-pin GPIO bus, plus I2C, SPI, and UART connections. There are 4 USB 3 ports and a Gigabit Ethernet port. It has a CSI video camera interface that's compatible with the Raspberry Pi version 2 camera. It has HDMI and DisplayPort outputs. Each support 4K video and they can both be used simultaneously. There is an M.2 Key socket for a Wi-Fi and Bluetooth adapter. You supply the Jetson Nano with 5-volt power using a micro USB or 2.1mm jack. So now let's start working with the Jetson Nano. So here's the Jetson Nano Development board. Now I've got it all hooked up, but I'm going to unhook it so we can take a better look at it. So I'm just going to disconnect this, which is the power supply, an Ethernet cable, a USB, which in my case is going to a keyboard and a mouse, and an HDMI. And we'll take the Nano board off. Now, before we look at the board, I just want to show you the box. The box came with this little stand, which is rather amusing. You place that in here, and then you can just place the board on here, and it gives you a convenient place to work on the board, which I guess is pretty cool. Now let's just take a look at this side of the board over here. As you can see, we have a series of jacks on there. The Ethernet, that's a Gigabit Ethernet. There are 4 USB 3 jacks. There is a HDMI and a DisplayPort output, and these can both be used simultaneously, by the way, both at 4K video. And over here is a barrel connector that you can use to supply 5 volts at up to 4 amperes if you want a higher ampere supply. Now this connector over here, the micro USB, is only used for an up to 2.5 ampere supply. So if you want to use this in high powered mode, you're going to need to use this power supply. And when you do use that power supply, there is a jumper here that you're going to have to jumper in order to take power from the barrel connector instead of the micro USB connector. Now down on here is a CSI connector. Not certain how well you can see that. That's the connector for the Raspberry Pi camera. There's a few other I/O connectors over here, power over Ethernet connector down here. Down on this side, you'll see a 40-pin connector. Now that's a 40-pin GPIO, and its output pins are programmable, but by default, this is the same GPIO that the Raspberry Pi uses. So you've got the ability to use some Raspberry Pi designs with the Nano, although of course you won't be able to put a hat on top of here because of the heatsink. Now the heatsink itself sits on the Nano module. The Nano module itself is an SO-DIMM module. It's mounted on a socket. I don't know if you can see the socket over here. And when you remove it, and you'll have to take these 2 screws off to remove it, there is another connector underneath that's an M2 type connector that can be used to add a Wi-Fi and Bluetooth connection to the Nano. Now you'll also notice that the heatsink has 4 threaded holes in it. This is for mounting a 40mm fan if you want, and this connector over here is for a 5-volt 40mm PWM controlled fan, so that's where you would connect it. And so that is the NVIDIA Nano in a nutshell, the Jetson Nano. So now that we've seen what the Nano is, I want to discuss for a few moments what the Nano is not. Now if you take a look at the Nano that I've got here on my workbench, you can see that it is a board that I have an HDMI cable, I've got a USB cable that's going to a keyboard and a mouse, I've got an Ethernet cable, as well as a power supply connection. And by looking at that, you would be forgiven for saying, well, this is a single board computer. Well, it's not a single board computer. For one thing, it's not a single board. It's a module sitting on top of a carrier board. And while that may seem to be a small distinction, it's actually a very big one. The idea with the Nano is that you can buy the Nano module separately, and the module you buy separately does not have a micro SD card on it. Instead, it has NVRAM on it. The idea is that you use this platform to develop code for the Nano module using the micro SD card, and then you burn that code onto the NVRAM. Because the Nano is a developer's platform. It is not a single board computer. I see a lot of people criticizing it because it doesn't have Wi-Fi and Bluetooth. I can understand the criticism. After all, the $10 Raspberry Pi 0W manages to squeeze Wi-Fi and Bluetooth onto it for that price. Why can't the Nano at 10 times the price have it as well? Well, again, the Wi-Fi and Bluetooth is not on the module. It's on the carrier board, and the carrier board does have place for a separate M2 module that you can add Wi-Fi and Bluetooth with. But it is not a single board computer. It is a development platform, and if you use Wi-Fi and Bluetooth in your application, then you would add that module to your application. Same deal with the video ports. It's got both DisplayPort and HDMI, but if your application doesn't need a video output, you wouldn't build that into your product, but you would put an SODIMM socket on your product to accept the Nano module. So now that we've got that out of the way, let's get some software installed onto our NVIDIA Nano. Now, NVIDIA has provided an excellent resource for getting started with the Nano, and I've got a link to that resource in the article that accompanies this video. The resource goes over the different components of the Nano and goes through what you're going to need to prepare for setup. So in addition to the Jetson Nano itself, you're going to need a microSD card. Now, they recommend a minimum of 16 gigabytes, but I would say that you want to use at least 32 gigabytes, if not more. You'll also need a micro USB power supply that can supply at least 2.5 amperes. Not all of them can, but you'll need that to power up the board. Of course, you're also going to need a keyboard, a mouse, and a video monitor as well. Now, in the next step, you write the image to the micro SD card, and this is where you get the image from over here, the Jetson Nano Developer Kit SD card image. Now, you're going to want to download that. Now, this is a large download. It's over 6 gigabytes, so if you're on a slow internet connection, this might take a bit of time. NVIDIA's also supplied instructions for Windows, for Mac, and for Linux for burning the card, although the basic instruction is as follows. You get the image, and then go and use an SD card burner. Now, if you don't have an SD card burner, the one that I would recommend is Etcher, and you'll also find a link to that in the article accompanying the video. I've used Etcher before in several videos to burn microSD and SD cards, so I won't show you it, but it's very simple. You just select where the image is, select the card you want to burn it to, and then let it go and do its business. And Etcher is available for Linux, for Mac, and for Windows. So once you get the image onto the card, it's time to place the card into the NVIDIA Jetson, and we can work on the installation now. So I've got my Nano hooked up again. I'm using the micro USB power supply in this particular case. It should be okay to bring the board up. Eventually I'm going to move to that power supply, however. I've connected an Ethernet cable. This is important to do when you're starting everything up. And you're going to also need to connect a keyboard and a mouse, and you can use the 4 USB jacks over here for it. I only have one connection because my keyboard and mouse are already connected together through an active USB hub on my workbench. And I've also connected a video monitor. Now, I've used an HDMI monitor. You could also use a DisplayPort monitor, and is connected into the appropriate connector. And then naturally you're going to need to put in your micro SD card. Now, the way the micro SD card goes is you take the contacts and have them up towards you, and if you look at the bottom of the Nano module, and I'm not sure if you can see that too easily, you will find the actual micro SD slot, and you'll just put the card into there. And again, I hope you can see that, a black card on a black background, and you press it in, and then the card will be installed. And so once you've got that micro SD card in, it is time to get our Nano working. Now, during the installation of the software, you'll see a lot of files being extracted and installed. It's essentially identical to the installation of Ubuntu Linux, because that is what we are installing. This just happens to be a customized version. Eventually, you'll end up on the system configuration screen over here, where they ask you to accept the term of the license agreement. So, we will do that and continue. We'll select our language, and we'll select a keyboard type. It asks where we are so that it can establish what time zone we're in. Toronto is close enough to where I am, so I'm going to continue. And now we have to give it some identification. Give the computer a name. And pick a username. and choose a password. And you can choose whether to log in automatically or require a password to log in. Look, a lot of people may find it convenient to log in automatically. I'm from the old school, which says I always need a password, so I'll set it this way. And now it is going to start to install a number of other files as well and complete the installation. And I'll skip the rest of the file install and just move ahead to the final results. After the files install and a number of reboots, you will finally end up at this screen, which is a standard Ubuntu 18.04 desktop. NVIDIA has added a few things to the desktop. They've added the Chromium web browser. They've also added a couple of links to the developer zone and to the support files online. Otherwise, this is essentially the same desktop that you would get with any installation of Ubuntu 18.04. So if you're familiar with the Ubuntu desktop, you're going to be familiar with this environment. And so that essentially is the installation of the software for the NVIDIA Jetson Nano. So now that we've set up our Nano, what exactly can we do with it? Well, NVIDIA has a number of resources up on their website, including Hello AI World, which is a series of steps that you can go through in order to demonstrate some of the capabilities of the Nano. They have demonstrations for things like image recognition and object classification. And Hello AI World is a great suite of tools to go through. And the next time that we get together and talk about the Nano, I intend to do exactly that and go through them so I can show you the AI capabilities of this device. But right now we don't really have the time to do that. Hello AI World is going to have to be the subject of an entire video because there is so much to it. However, I thought it would be a good idea to test the capabilities of the Nano, so I wanted to run at least a couple of demos in order to do that. One other thing I wanted to mention about setting up the Nano is the size of the microSD card. I neglected to mention that before. Now, if you look in the documentations for the Nano, it will specify a minimum of a 16 gigabyte microSD. Well, 16 gigabyte is really not a realistic assumption. You need to use at least 32. In fact, what I've used over here is both of these cards, and they've both worked very well for me. I've got a 64 and a 128 gigabyte card. These are both Kingston cards. I heard a few people on the forums saying specific SD cards weren't working well for them. These Kingston cards seem to work pretty good for me. I'm not advertising Kingston, but they were a good value. The cost difference between the 64 and the 128 gig card was only about $5 US. So if I were you, I'd go for the 128 gig and leave yourself a lot of room for experimenting. So let's take a look at a few things now that we can do with our NVIDIA Jetson Nano. So let's take a look at what we can do to demonstrate the power of the NVIDIA Jetson Nano. Now, included with the installation are a number of different applications and example programs. Now, these actually need to be built. You can't just go and run them. And I've built a number of the CUDA samples. Now, CUDA is a parallel processing platform that NVIDIA has created. And they have a number of sample applications. As I said, you have to build these, and the build process takes a little while. It takes about 2.5 hours or so to run it on the Jetson Nano. And one thing I'd advise when you do this is keep your hand off the heatsink because it actually gets very, very warm. Once you've completed the build process, and I have instructions for doing the build process in the article accompanying this video if you want to do this as well, you will find that there are a number of different demonstrations over here. Now, some of these demonstrations simply do mathematical calculations and come up with numbers, and they can be used for benchmarking. Other ones are more graphical in nature, and as you can see, there are quite a few of them. I was playing around with them, and I found 3 of them that I thought were amusing, so let's give them a try. Here's one called Ocean FFT, Fast Fourier Transform. And here's our ocean, and we can use our mouse to make our ocean move around. Let's make it a bit bigger, and I can move the application around, and I can zoom in and zoom out, etc. Now remember, every one of these points is being calculated right now, so this is basically a test of raw computing power. Okay, let's try another demonstration here. Smoke particles. Now this is an interesting one. And in this demonstration, as the particles disperse, you can use your mouse to move around the room and you'll see the shadows of the particles as reference to the light source, which is behind the particle there. You're just seeing the light source right now. But again, every dot over here is being calculated, and so it's a illustration of how much data this can calculate in a very short period of time. Okay, and we've done smoke particles, ocean, where's the random fog? There we go. Now in this one you use the keyboard to manipulate it, and they give you instructions over here for doing it. And so you can, if you want to, you can zoom this 10 times. Again, each one of these points is actually being calculated. The lines represent the axis that this is going in. And you can use some of the keys on your keyboard to change the rotation. I'm changing the axis over here. Again, this is a representation of how many calculations this can make in a given period of time. Okay, so those are just 3 of the examples that I wanted to show you. There are, as you saw, many, many more of them. You can also try doing things such as running video, etc. onto the platform. I tried a few YouTube videos. Everything is very fast and responsive, and as a single board computer, even though it isn't one, it would actually be a very good machine for $100. But of course, we know it's capable of much, much more. So that wraps up our look at the Nano for today, but by no means is this the last time that we are going to be seeing the NVIDIA Jetson Nano. Now, I have, as I said, bought 2 Nanos, and one of these Nanos is intended for my Build-A-Real Robot project. So for those of you who are following the construction of the DB1 robot, I will be using an NVIDIA Jetson Nano as part of that design. So you'll be seeing a lot of that later. Now, for those of you just following the workshop videos, the next time that we get together to talk about the Nano, I'm going to be running the Hello AI World applications that NVIDIA has provided. Now, these are a set of demonstrations that will show you some of the capabilities of the Nano. Some of its object detection and object recognition capabilities are shown in Hello AI World. And we're going to see how we can train our Nano to recognize specific objects. Now, after that, we've also got to install some extra hardware onto the Nano. So I'll be doing another video showing you how to set up both the Bluetooth and Wi-Fi module, as well as the PWM controlled fan that can bolt onto the heatsink. And finally, there is a really cool Nano project that I want to make use of. It is something called a JetBot. Now, the JetBot is a small robot car. It's a small 2-wheel robot car. It's completely open source, and you can build it with essentially a Jetson Nano, a little power supply for it, a little USB supply, a Raspberry Pi 2 video camera, and a robot car base. So I'm going to be putting one of those together. Now, as I said, all of the code for the JetBot is open source, so you can look it up and start building one yourself right now. They also give you STL files if you want to print a 3D chassis for it, but I'm going to just use a standard robot car chassis. So there is a lot that we are going to be doing with the NVIDIA Jetson Nano in the future. Now, if you want to stay informed about all those videos, the best way to do that is to subscribe to the YouTube channel. So please hit the subscribe button. I would very much appreciate that. And as always, you will find an article accompanying this video on the DronebotWorkshop.com website. There's a link below the video to that. And when you're on the website, please sign up for the newsletter so we can stay in touch with each other. So until we meet the next time, please take care of yourselves, and I hope to see you again very soon here in the workshop. Goodbye for now.